In this problem, we're given a couple of angles and the quadrant in which those angles exist, and lastly, a ratio of the sides of the triangle with that angle. So for instance, alpha here is in quadrant 1, and so we can draw it as such. It's in quadrant 1. Notice that cosine is equal to 8/17, and that implies that adjacent over hypotenuse is 8/17. So this would be a fair ratio for that alpha right here. One thing to keep in mind is that we might need to actually know what some other functions of alpha are. So we might need to know what the opposite is. So why don't we find the opposite, and that'll help us find those other functions. Well, this is a right triangle, so we can use Pythagorean theorem. That is 17 squared equals 8 squared plus, and we can call this, let's say, y, plus y squared. 17 squared is, let's pull up a calculator real quick. I end up with 17 times 17 is 289. I'll also need to move them to one side. That means subtract. So I have y squared is equal to 289. 8 squared is 64, so minus 64 is 225. That means that y is equal to plus or minus the square root of 225, which is just 15. So plus or minus 15. And our question is, well, is it plus or is it minus? Well, it's a y value in the first quadrant, which has only positive values, so it's only positive. So our y is 15. Then we can figure out some trig functions of alpha. So for instance, sine of alpha is just equal to opposite over hypotenuse, or 15/17. And we are given cosine of alpha, which is 8/17. We can find tangent of alpha, which actually answers part A for us, which is 15/8. Whoops. 15/8. And some of the reciprocal functions can be found as well, which is just the reciprocal of these. Now, we might want to do the same thing for beta. Notice that beta here, 7/24, is in the third quadrant. It's between 180 and 270 degrees, the cotangent of which is equal to 7/24. So why don't we draw another picture and find out some of those same values. So you might be wondering, why am I going through all this work, right? We have some questions up there. I could just go, I can go across each one and simply answer them, right? Well, I think this streamlines the process quite a bit. So notice that a lot of these you'll have to use some formulas for. Cosine of 2 beta can be written using any of the cosine double angle formulas, some of which might reference cosine of beta, which isn't given, right? We have cotangent of beta, so it might be helpful to know what cosine of beta is, and that's what we're finding out here. Cotangent is 7/24. Cotangent is adjacent over opposite, so we have 7 and 24. And one thing to remember is that this is in the third quadrant. That quadrant information is really helpful because it tells us whether the x or y's should be negative. Here, both should be in the third quadrant. All right, and similarly, we might want to know what the hypotenuse is, so we will square the components. Negative 24 squared plus negative 7 squared, and that should equal the hypotenuse squared, which we'll call c. So c squared then is equal to 24 squared plus 7 squared, which then I arrive at 576 plus 49. 576 plus 49 I have as 625. All right. The square root of 625 is just 25, thankfully. So we have plus or minus 25, and we deal with that same problem, is it plus or minus? And here I can tell it's a hypotenuse, and the hypotenuse is always positive. Pretty straightforward. So this is just 25. All right, and again, we can create some formulas out of these. So sine beta this time, and note that our angle beta is right here. Sine of beta is opposite over hypotenuse, which is negative 24/25. Cosine beta is adjacent over hypotenuse, so negative 7/25. And tangent of beta is opposite over adjacent, so it is 24/7, which makes sense given that cotangent of beta is 7/24. All right, so we have all this information now, all these trig functions. What we want to find out is one of these answers. I'll pick one at random just as an example, but note that during a test you may be expected to answer all of them, in which case all of these relationships will be really helpful. So let's pick, let's say, part E here. So part E says we need to find, I believe it's sine of alpha plus beta. And we'll have to think of the formula for alpha plus beta inside of a sine. And if you recall, it looks something a little bit like this. Sine of alpha cosine of beta plus cosine of alpha, alpha sine of beta. And luckily, we actually know exactly what all these values are. Sine of alpha is 15/17, excuse me. Cosine of beta is negative 7/25. The cosine of alpha here is 8/17. And finally, sine of beta is negative 24/25. And this is a job for a calculator here. We can get some values once we simplify this. 15/17 times negative 7/25 plus 8/17 times negative 24/25. And the value I end up with is negative 297/4/25. And that would be sine of alpha plus beta.